Let us solve a question on linear equations. The question is, the linear system of equations x plus y is equal to 3 and another equation is x plus k square minus 8 times y is equal to k for k is a real number, has no solution for k is equal to what? We need to find out the value of k for which the given system of equations have no solution. Okay. So first thing is we write the given system of equations in matrix form. Okay, so in matrix form that is A into x is equal to b. A denotes the coefficient matrix, and let me write it here. The coefficients of x's and y's, and x denotes the solution vector that we need to find out the value of x and y, and b is the vector of constant terms. So what is our coefficient, rather the coefficient matrix? That is the coefficient of x's in the two equations is 1 and 1, and the coefficients of y's, you can see the coefficient of y in the first equation is 1 and the coefficient of y in the second equation is k square minus 8. This is our coefficient matrix. To this we multiply the solution vector, that is x and y. This is called a solution vector, and it should be equal to the vector of constant terms, which is 3 and k. Okay, so 3 and k denote the vector of constant terms. So we have written the given system of equations in matrix form. So we will be applying here Cramer's rule, and I will explain how do we find out the value of k for which the given system of equations have no solution. Okay, if we apply Cramer's rule, okay, Cramer's rule, first thing is to apply Cramer's rule, what will we do? We first find out the determinant of a. Okay, so here what is the determinant of a? So we multiply these two elements first, so that is k square minus 8, that is 1 into k square minus 8. From this we subtract the product of these two elements. Okay, let us say this is the determinant of a. Then to find out the value of x, we form a new matrix. Okay, I'm just trying to show how do we apply Cramer's rule, then I will apply, explain how to get the zero solution. Sorry, this the value of k for which the given system of equation have no solution. So to find out the value of x, okay, what we do, we form a new matrix A1 such that we replace the first column of the coefficient matrix with the vector of constant terms. So we have, in place of 1 1 we have 3k, then we have 1 k square minus 8. Okay, similarly to find out the value of y, okay, then let me write it here. Then what will be the value of x, which implies x will be equal to the determinant of a1, and let me write it here, only a1, I have not taken the determinant here, divided by the determinant of the coefficient matrix. In the same manner, to find out the value of y, what will we do? We form a new matrix. Okay, to find out the value of x, we replace the first column. To find out the value of y, we replace the second column. So we have 1 1 1 1 first, then we have, in place of this we write 3k. Okay, 3k, then the value of y will be equal to the determinant of this new matrix A2 divided by coefficient matrix. Okay, this is how do we apply the Cramer's rule. Now let us see what the question says and what this determinant plays. How does the determinant plays the role, the determinant of the coefficient matrix? Now if ax is equal to b, here we have written in this fashion, and if the determinant of the coefficient matrix is not equal to 0, in this case we have a unique solution. Okay, but if the determinant of the coefficient matrix is 0, then we have two possibilities. If at least one numerator determinant is 0, we have infinitely many solutions. The thing is that, so let us say this is numerator determinant, and in this case we have this numerator determinant. If the determinant of a1 is equal to 0, or if the determinant of a2 is equal to 0, in this case we will have infinitely many solutions. Okay, if none of the numerator determinant is 0, if both a1 and a2 their determinant are not equal to 0, then in this case we have no solution. Okay, now let's first try to find out. First thing is the determinant should be equal to 0, so we set this equal to 0, the determinant of the coefficient matrix equal to 0. When it is equal to 0, then what happens? So we have k square will be equal to 9, which implies k will be equal to plus minus 3. Here you can see simple thing, which implies k is equal to 3, and again we get two values for k. Okay, k is either 3 or k is equal to minus 3. Okay, now when k is equal to 3, we are just trying to find out the case for no solution. When k is equal to 3, then what is the determinant of a1? So when k is equal to 3, let us find out the determinant of this. So how do we find determinant? We multiply these two elements first. So we have 3 into k square minus 3 8s are 24. From this we subtract k. So when k is equal to 3, that means 3 into 3 square minus 24 minus 3. So this is 9 3s are 27 minus 27, which is equal to 0. So when k is equal to 3, a1 comes out to be 0. That means at least one numerator determinant is 0 here. So when k is equal to 3, we will get infinitely many solutions. Okay, so k cannot be equal to 3 for no solution. Then when k is equal to minus 3, so what will be the determinant of a1? Okay, we don't need to check for a2 here, because since the determinant of a1 comes out to be 0, it is enough to prove that we will have infinitely many solutions. Now let us check for when k is equal to 3, minus 3 rather. So what will be the determinant in this case? Again, so determinant is equal to, we have 3k square minus 24 minus k. So in place of k we have this time minus 3. So we have minus 3 square minus 24 minus, then we have in place of k we have minus 3. So here you can see 3 3s are 9 3s are 27 minus 24 plus 9. Okay, here it comes out to be am I doing it correctly or not? So we have 27 so now I guess it is equal to 11, and it is not equal to 0 here. Here we see that a1 is equal to 11, which is not equal to 0. And we have to see for a2 also. Okay, so what will be a2? When k is equal to minus 3, let's take the determinant of a2. So the determinant of a2 will be equal to, multiplying these two elements first, we get k, then we subtract and multiply these two elements minus 3. So we get minus 3 and minus 3. So a2 is equal to minus 6, which is also not equal to 0. So both conditions are satisfied when k is equal to minus 3. That implies, first thing is we set the coefficient matrix equal to 0, and here we got two values for k, that is k is equal to 3 and minus 3. And now to check which of these two values of k give us no solution, we have to form the new matrices a1 and a2 and take their determinant. When k is equal to 3, the numerator determinant of a1 comes out to be 0. So we can say that when a1 is equal to 0, so at least one of the numerator determinant is 0, so it will give us infinitely many solutions. So this is not our headache. We need to find out when it will give us no solution. So we switch from k is equal to 3 to k is equal to minus 3 to check. When k is equal to minus 3, we can see the determinant of a1, which is the numerator determinant, it is not equal to 0. And similarly we check for a2. Okay, here you can see a2 also comes out to be is not equal to 0 when k is equal to minus 3. That means the system of equations will have no solution only when the value of k is -3. So here we have -3. I hope I make myself clear in this video. Thank you.